today we will be discussing on chapter 2, which is equations, inequalities and absolute values, and hopefully this will be a short video on discussing the questions which I'll be presenting right now. So these questions I'll be referring to one of my books, which is the previous year's real exam questions from matriculation program from 1999 to 2020. So today's video, my goal is to give you a broad view on how to answer this type of questions, and hopefully this might help you a bit or enough to give you an idea on how to solve them. So equations, for today's video, equations is all about solving them, whether we have a quadratic function or you have to replace it with a dumb variable, etc. And we have to know as well the definitions for which we want to choose which value satisfies the equation itself. Okay, and we also be using properties and etc. And then for inequalities, when we in secondary school we'll be learning inequalities in a simpler way, but now we will be dealing with rational functions, and there are methods on how to solve, like table of signs and the real number line to determine on which of the values of x satisfies the inequality. And the last will be absolute values, where we will be going through with the definition of absolute value, where it's for real numbers. Okay, don't get confused with complex numbers, that's another term, but for now, absolute values, we are dealing with real numbers. Okay, hopefully that gives you some perspective on what we'll be learning, and hopefully we could cover most of what I'm about to show you today. Okay, right, so let me see here. Okay, I'll go through with the first subtopic, which is equations, and let's start with a simple one. Okay, so this question is from 2003. So we are given 5 multiplied with ln 3x minus 10 is equal to ln 32. So it's a simple one, and to solve this we can rearrange the terms, like group the ln terms first and the constant terms on the right hand side. Or technically I'm saying that, okay, I'll be adding 10 both sides and I'll be subtracting ln 32 both sides. So 5 ln 3x minus 10, so I'll be adding 10 and I'll be subtracting ln 32. So this is the same as on my right hand side over here. Okay, now eliminating those terms gives us the following, which is 5 ln 3x and then minus ln 32 is equal to 10. Now one of the properties for logarithms is that we can bring this coefficient in front of the ln, or the constant multiple in front of the ln, to become the exponent. So it will be ln 3x power 5 minus ln 32 is equal to 10. Now from here we will be applying the properties of logarithms, which is the difference between two lns or two log terms. We can combine them to become a single term, which is we'll be dividing them. So ln 3x over to power 5 divided by 32 is equal to 10. Then we can simplify this further. We know that we can raise e both sides, so it'll be e to the power of, let me write this better, e to the power of ln 3x power of 5 over 32 is equal to e to the power of 10. So from here we can eliminate this because they have the same base and the same log base. Now we are left with 3x to the power of 5 over 32 is equal to e to the power of 10. Okay. And now what we can do here is, by rearranging this, 3x to the power of 5, and we know that 32 is equivalent to 2 to the power of 5. 2 to the power of 5 e to the power of 10. So what we can do now here is that we can we can put a fifth root, or we raise 1 over 5 both sides, So we are left with 3x power 5 over 5 is equal to 2 to the power of 5 e to the power of 10 to the power of 1 over 5, and we can use the laws of indices, and then we can solve this equation very nicely. And we are left with 3x is equal to 2 e to the power of 2, and then we can solve for x, which is 2 e to the power of 2 over 3. So this satisfies the equation nonetheless, because since this is a positive number larger than 0, you could see that it satisfies the equation. Okay, but if you're given the situation where you have two answers, so it's best to check whether or not it satisfies the equation itself. Okay, so let's solve another question related to equations, and yeah. And here we have an exponential equation where we have to solve for such value, and usually most of the students from matriculated program have some trouble with this, because we have to replace it with a dummy variable to see what kind of equation it is, or what kind of polynomial it is, because, well, we are replacing some variable, and then if it's a polynomial, then to the degree of what, 3, 2, etc. So let us see, this question is given as 7 to the power of 2x minus 7 to the power of x plus 1 plus 4 is equal to 0. Okay, now first things first, let us talk about the laws of indices. So the first law will be a to the power of m plus n, and I'll be talking about the ones where they have equivalent bases. In this case, it will be base of a. So if they have the same base, then we can, n is equivalent to this, a to the power of m times a to the power of n, and this is also equivalent to a to the power of m times with a to the power of n, or you could write like this, a to the power of m, a to the power of n. I think that's because we are still looking as a product of two terms, so yeah. Anyway, negative 7 to the power of x plus 1. So the negative sign is not included, meaning that you can't just say negative 7x times negative 7. No, negative is just a separate operation, so don't include them on, well, let me show you. So 7 to the power of 2x minus 7 to the power of x times 7. Okay, so that's what I'm talking about, right? So don't get too confused on what I'm doing. So plus 4 is equal to 0, and now I want to talk about another property or another law, which is, let's say we have a to the power of m to the power of n. So this is equivalent to a to the power of n to the power of m. Oh, by the way, a, in this case, I'll be talking about a larger than 0, right? So I forgot about that. M and n are real numbers, right? Then a has to be larger than 0, and a is also a real number. But if I'm wrong in that case, please do correct me. But anyway, so the reason why I'm showing this is because before we want to replace with a dummy variable, I would like to have equal terms, meaning that, okay, let's say a to the power of x, I'll replace it with y. So each a power of x will be replaced with y, but in this case, my first term, which is 7 to the power of 2x, I haven't, well, it's not equivalent to the second term, which is 7 to the power of x. So the power itself, I have to rearrange it so that I can substitute the dummy variable very clearer. So in this case, I will have 7 to the power of x to the power of 2, then minus 7 to the power of x times with 7 plus with 4 is equal to 0. Now, as you can see, we have one term, one variable, which is we can substitute to a dummy variable. So 7 power of x will be what will be equivalent to any variable you want to. In this case, I'll be replacing with, let's say, a variable y. So let y is equal to 7 to the power of x, and all the terms that has 7 power of x will be replaced with y. So the reason why we're doing this is because that we can recognize this equation as a quadratic equation, and we know methods to solve the quadratic equation very nicely. So y squared minus 7y plus 4 is equal to 0. Now, secondary school, you know how to solve these kind of equations, whether you use a calculator or you can use such methods. So let's solve this quadratic equation. So I have here 7 y squared 7, yeah, plus 4. Wait, let me use the quadratic formula. Well, okay, since the time is in our essence, I will not be very. Let me use my calculator real quick. So 1 minus 7 plus 4. So now we have a irrational value, which is we have y is equal to 7 plus square root of 33 divided by 2, or y is equal to 7 minus square root of 33 over 2. Oh yeah, for working wise, please to show you're working by using the quadratic formula, which is negative b plus minus b squared minus 4ac divided by 2a. So this is a part of your working, but for time purposes, I'll be just writing the final answer itself. Okay, so right now we have two answers. And how do we determine the value of x? We replace this dummy variable back into our original substitution and solve for x. So we have the first value, which is 7x is equal to 7 plus square root of 33 over 2. And to solve this, oh, by the way, I'm leaving it as the exact value. Okay, how do I leave this? The way you're going to do it is by log both sides. You will be placing log base 10. So technically you'll be log, since for your syllabus we already define log as base 10. So log 7x is equal to log 7 plus square root of 33 over 2. And then previously we talked about properties of logarithms, where x can be put in front as a multiple of the logarithm itself. So we have x log 7 is equal to log 7 plus square root of 33 over 2. And then finally we have x is equal to log 7 plus square root of 33 over 2 log 7. So there you go, that's your first solution. Now how about your second solution? Your second solution is the same thing as what you did here, by placing log base 10 both sides. So let me show you directly here. So 7 power of x is equal to 7 minus square root of 33 over 2. We log both sides like this. Oops, sorry, give me a second, I want to rearrange my setup here correctly. Oops, okay. Okay, so log, placing log both sides like this. You can solve for x, which is log 7 minus square root of 33 over 2 divided by log 7. Oh, by the way, I forgot to mention, check whether or not this is a negative value. If this is a negative value, then it can't be the answer, because 7 power of x, since 7 is larger than 0, so it has to be a positive value, which means that it has to have a value which is larger than 0. So let's say if 7 minus square root of 33 over 2 is less than 0, it's a negative value, a negative number, then it's not a solution, because it contradicts on what we have on the left hand side. The left hand side, we know that's always positive, but then the right hand side all of a sudden it gives us a negative value, so we can ignore that solution. But in this case, both the final answers for y is a positive value, therefore both solutions are acceptable. Okay, alright, so let's jump into another question. Let me find one real quick. Okay, Now this is an interesting one. We have a question given log x base 6 log x power of 3 base 6 minus 2 times log 6 base x log of 6 base x is equal to 1. So the reason why it's interesting is because I want to talk about the conditions for x here as a base itself. So what are the conditions? Well, firstly, this x can be any positive number. Positive number means that it could be a real number, integer, whatever. Okay, positive number, except for it can't be 1. It can't be equal to 1. So the way we talk this is that x can be larger than 0. X cannot be 1. So that is about it. Okay, so x are real numbers in the real number set. Okay. Alright. So what we're going to do is we're going to talk about another property for logarithms is changing the base of log. So I'm gonna give you a general example. Let's say we have log AB. Okay, log AB. So to change the base, simply will be log CB over log CA. So the base and then the base of log, it will be on the numerator, the base itself, and then the denominator will be the base for the log. Then C is the log, the base which you want to convert it to. Okay. Hopefully this gives you a general idea on what I'm about to do. So right now, I could see that my problem is that how do I solve this? Because I can't solve it directly. It's not a polynomial. It's nothing that I can recognize to solve it. So what I'm going to do is that we're going to make a same term. So in this case, I would like to make it the same. How about for the second term, which is log 6 base x, I want to change it to base of 6. Why not? Remember, as long as it's a positive number, which is larger than 0, it's not equal to 1, then the way I'm doing it is acceptable or logical speaking by definition itself. So over here, I'm going to rewrite again the first term and then changing this to base 6. So here we go. Very nice. And another cool property of logarithms is that if the base and the base of log itself are equal, meaning that they have the same value, then is equivalent to 1, right? So log 6 base of 6 will be equivalent to 1. So let me rub this off, then it'll be 1. So now, okay, this looks interesting. And before we proceed any further, I want to talk about the power tree, which is for the first term, log x base of 6, log x power of 3 base of 6, which is this term. Okay, so remember previously we talked about the properties of logarithms. So the power of 3 could be bring a fun as a multiple, so 3 times log x base of 6. So we have 3 log 6x log x base of 6 minus 2 over log x base of 6 is equal to 1. Now we have some terms that we could recognize. The first one will be log x base of 6, and we can replace it with a dummy variable. Okay, so by replacing it with a dummy variable, we recognize this particular equation, but it's not a polynomial yet. Okay, but we can recognize it. So by replacing a dummy variable, in this case, let's say let y is equal to log x base 6. So all the terms will be replaced with y. So 3y minus 2 over y is equal to 1. Now to make it as a polynomial, I have to multiply both sides with y, with the condition that y cannot be 0. If y is 0, then obviously it's undefined in this case, which y is on the denominator and you can't make it as 0. So yeah, that's the condition, but hopefully you guys remember on why are we doing this. Okay, so we don't consider 0 as a solution for y, which it contradicts this equation itself. Okay, so by multiplying both sides of y, we could have 3y squared minus 2 is equal to y, and we will be rearrange this to become a quadratic equation, because we recognize and how to solve those are straightforward. So 3y squared minus y minus 2 is equal to 0. And finally, solve it as usual. So we have negative 6. Let me think first. So 3y squared minus 3y plus 2y minus 2 is equal to 0. We have 3y, y minus 1 plus 2, y minus 1. So now we have two solutions. The first one will be y is equal to, sorry, let me factorize it first. 3y plus 2 is equal times with y minus 1 is equal to 0, and we have 3y plus 2 is equal to 0, or y minus 1 is equal to 0. Therefore, y is equal to negative 2 over 3, or y is equal to 1. Alright, so now this is an important part. It's an important, no, it's not an important part. Just basically replacing back into the variable that you replace with. So you have firstly log of x base 6 is equal to negative 2 over 3, and then we have log x base of 6 is equal to 1. So here you can solve it nicely. 6 power of negative 2 over 3. The last one will be x is equal to 6. Okay, which is very nice. And I'll be leaving it as a exact value, because that is how we do it. We leave it as a exact value, which is this. Okay, so far we've done 3 questions for equations. Let me see, can I find anything else? I mean, I have a lot of questions here, 40 of such. But if I think that it should be no problem, so far nothing, honestly. Wait, nothing. Okay, I guess that should be enough for logarithms. Okay, oh, you know, should be enough. Okay, so I think equations is not a problem. As long as you know your definitions, as long as you know the property itself, then it should be no problem. It's like revising at maths, basically. So now let's jump into the next part, which is inequalities. Now, inequalities, back in high school, or secondary school, we learn about solving inequalities for quadratic equations. That's basically about it, and graphing them. Now we will be dealing with other functions like rational functions, etc. So there are methods to solve. There are 2 at the moment. The first one will be table of signs. The second will be real number line. So I'll be showing you 2 methods, and yeah. Sometimes people ask me, when can we know on which method should we use? The answer is, I'm not pretty sure, because well, you can do whatever you like. That's the idea. You can do which method you are comfortable with. So let's try and solve one of the equations. Okay, let's say we have 2x plus 1. Let me show you a direct first, then we could go into this one. So let me find it. Sure, here. This should be sufficient enough. Oh no, this one. So let's say we have 1 over 5 minus 3x less than 1 over x plus 2. So for this one, usually students, they multiply both sides with the denominator, and then they have I believe a linear function, then they solve it directly. But later I'll try to solve that way and see why it doesn't work. Okay, so let's try. So the right way is by subtracting both sides with either you want to take away this one to become 0, or you want to make it this one 0. Is up to you. Okay, so for me, I'll approach this by subtracting 1 over x plus 2. So we have 1 divided by 5 minus 3x minus 1 over x plus 2 less than 0, and we can combine these two fractions to become a single fraction. It becomes x plus 2 minus 5 plus 3x. Here I expand my negative directly, so but if you guys want to show that you're working, then it should be fine. Okay, hopefully that should not be a problem. Divided by the product of 5 minus 3x and then x plus 2 less than 0. Now for our numerator, we can simplify it, so it becomes 4x minus 3 divided by 5 minus 3x times with x plus 2 less than 0. Alright, so there are two methods on how to solve this. The first one will be table signs, where we create our intervals and we determine on which parts satisfies the inequality. Or the second method, which is real number line, where based on the factors we have, we create some lines and then we determine each part whether it satisfies the inequality. So let me show you without chatting too much. But first I have to sketch something to determine the endpoints for my interval. To be precise, open intervals. Okay, so where's my color? So here it is. So this is a sketch area. I would like to determine my x values, my endpoints. So 4x minus 3 is equal to 0. So my first endpoint will be x is equal to 3 over 4. Sorry, I think yellow is not a suitable color to be used. I think this should be enough. Okay, so let me do it again. Sketch. We have 4x minus 3 is equal to 0, which implies that x is equal to 3 over 4. And then we have 5 minus 3x is equal to 0, which also implies x is equal to 3 over 5. Sorry, 5 over 3. Then lastly will be x plus 2. X plus 2 is equal to 0, which implies that x is equal to negative 2. So now we have 3 endpoints, and we will be arranging them accordingly from the smallest to biggest. So the first interval will be from negative infinity. Negative infinity. Sorry, let me do it on a black pen. Negative infinity up until our first smallest value, which is negative 2. And then our second interval will be negative 2 up until our second largest value, which is 3 over 4. Then finally will be from 3 over 4 to 5 over 3. And then, lastly 5 over 3 to infinity. So basically we are considering all numbers that is a possibility for our inequality, except for those endpoints. So those are open intervals, which they are not included. Remember back in chapter 1. So negative 2, 3 over 4, 5 over 3, those are the endpoints where they are not including it into our interval. So the second step is writing out the factors on our left hand side. Okay, so first will be 4x minus 3, and then 5 minus 3x, and then x plus 2. And then finally, our important row will be, we call it as the solution. That solution means that we will be determining the part of where it satisfies inequality. So we will be dealing with positive or negative signs. Okay. So here we write that as 4x minus 3, then divided by 5 minus 3x, x plus 2. Okay, very good so far. Now third step will be determining on which values between those two intervals, meaning that between negative infinity and negative 2, I would like to pick a value where what kind of value it gives me, a negative value or positive value. So in this case, for our first interval, I would like to choose negative 3. It's a simple negative integer, which I could replace it in my factors accordingly. and determine their signs. So negative 3. Now second interval, the easiest one will be 0. Then the third interval will be 1, much more simpler. And then the last one will be, let's say 2. Wait, 5/3. Let me check. 5/3. Yeah, 2. So now we have 4 values, which we will be replacing them into factors respectively to determine the signs. That's why the method is called table of signs. So the first one, negative 3, replace it. So it will give us a negative sign. So let me write down first negative, and then positive, then negative. Okay. So now as you can see, when you place that in this term, they will have a positive sign. Or to make it clearer, this, you multiply this sign, you have a positive sign, multiply this sign, you have a positive sign. So that is your conclusion. So this is the same goes for the rest. Replace 0, you get negative, positive, positive, and negative. Okay. Replace 1, you'll have positive, 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 and the last one will be positive, negative, positive will be negative. So now in this part of your working over here is essential, because it will be determined based on our inequality sign, whether it's less than 0, larger than 0. Okay, so less than 0 implies negative numbers. So the section that we'll be choosing is the negative sign, obviously. Alright, so that is about it, and yeah, that is the method itself. So sorry, it's a typo. Okay, so yeah, that's about it. So oops, pencil. So this one and this one are the parts where we're going to basically, that is our answer, which satisfies the inequality. Okay, so this is an interval solution. Okay, I'll be showing you 2 solutions so that you could have an idea on the notations that we'll be using. So the first one will be the interval notation. So it will be negative 2, 3/4, union with 5/3 to infinity. Okay. Now the second way to show is by using set Boolean notation. And set Boolean notation, we have 2 ways. The first one will be curly braces, x such that x are real numbers such that negative 2 x 3/4 or x is larger than 5/3. Or there's another way to show x such that x are real numbers such that negative 2 less than x less than 3/4 union with x such that x is larger than 5/3. Okay. But if there are any problems on me writing the notations, please do let me know so that I could pin it if you can. Alright, so that's about it mostly. Now this is what you call table of signs. Okay. Now how about another method, which is real number lines? So real number lines, more or less like table of signs, but you are using lines to determine the parts of the range of values of x. Okay. So let me write down, let me draw one line here, let me make it bigger. So bigger, a big line here. And so the first one is, by referring back to our sketch, we plot the points, we plot on our line the values of x. So it'd be negative 2, 3/4, 5/3. So here we'll start with negative 2, 5/3, and 3/4. Now the problem is, we want to know which part respectively the values becomes a positive value or negative value. So let me write down the factors first. So 4x minus 3, 5 minus 3x, and then x plus 2. So you have these three factors, three terms here. So on which part of values of x does it becomes a negative value entirely? Now you might be confused on what do I mean by that. 4x minus 3, when does it become a negative value? 5 minus 3x, when does it become a positive value, and etc. So that is the essence of what I'm about to show. Let me write this much more clearly. So it'll be 3 over 4, 5 over 3. Okay. So we want to know when does 4x minus 3 becomes larger than 0. So by solving this algebraically, okay, I assume that all of you know how to solve it. Okay, so x will be larger than 3 over 4. So what does this mean? This means that whenever x is larger than 3 over 4, this term becomes a positive value. And whenever x is less than 3 over 4, then that term becomes a negative value. So that is what we're going to do. And we will be creating a line by referring to that idea that we had. So let me write down 3 over 4 up until infinity. This becomes a positive value. In other words, on the line it's a positive sign, without the line it's a negative sign. So essentially this is a positive, this is a negative. Positive negative means that the term 4x minus 3 becomes positive when x is larger than 3 over 4. 4x minus 3 becomes a negative term if it's less than 3 over 4. So that's basically what I'm doing. Okay, so let me do the rest. So for 5 minus 3x, when does it becomes a positive value? Where x is less than 5 over 3. So the way you write this as so from 5 over 3 up until negative infinity, the term itself 5 minus 3x becomes a positive value, okay, and vice versa. So finally we have x plus 2, so I'm going to do it directly. So we have this up until infinity. So we know on the line the term itself becomes a positive value, so plus, 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 negative. So in this part we have 1, 2, 3, 4 sections that we have to determine. Okay, so that is the idea we're about to do. And then without the line is negative, with the line is positive, then finally positive, positive, negative, negative. So the important part is down here. Bottom here, yep. So sorry. So the way we want to determine the signs down here, the signs that we have to obtain, is that we multiply all the signs. So we multiply it, becomes a negative sign. We multiply this part, we'll have a positive sign, negative sign, positive sign. So since we are referring back to our inequality where it is less than 0, so the sections where it is a negative sign satisfies the inequality. Therefore I'll be writing this down as an interval notation. So it'll be negative 2 and then 3 over 4 union with 5 over 3 to infinity. Okay, so that's basically about it, those two methods. Okay. Hopefully it gives you a good idea on how to do it, right? So that's basically about it. If I just multiply both sides, what happens? Let's try. So what if I rewrite the inequality, but then I first multiply with x plus 2, 5 minus 3 of x, 3x, sorry. Then I simplify it. Now I have 4x larger than 3, that x is larger than 3/4. Okay, so x is larger than 3/4. Well, this is untrue. This inequality itself doesn't satisfy the inequality that we have. So let's say, alright, so 3/4, right? So let's say 1. Based on this answer alone, we pick x is equal to 1. Now the question is, does it satisfy? Does it satisfy? So x is equal to 1. Wait, 5x. Hey, sorry. This is the wrong sign. Less than. Right? Sorry. I think the original question is less than, right? Yeah. Less than. So my apologies. Less than. Okay. So yeah, going back. Yeah. So the question is, okay, x is less than 3/4. Means that 3/4 up until negative infinity. Well, firstly, it doesn't include the other answers which satisfies the inequality, which is 5/3 to infinity. So okay, based on the answer we have, x is less than 3/4. Let's say we take -5. Well, -5, it still satisfies the inequality. So x is -5. So what happens? Does it satisfy this inequality? So 1 divided by 5 minus 3 times 5, then we have 1 over x, 5 plus 2. So 1 minus 7, 5, 4x, yeah, 4x 3/4. Sorry, not 5, -5. Yes, -5. Okay, so when we solve this, what do you expect? Well, it doesn't satisfy. 15, 20, 1/20 less than -1/3. So when you directly solve this method, not only it gives us the wrong ranges of values of x, but it also excludes the other values, the range of values of x, which satisfies the inequality, which is 5/3 to infinity. So that's basically about it. Okay, we can't just, well, there are other cases where you could do this. There are cases, but in this case, no, because firstly, x plus 2, there are parts where it becomes negative or positive value. 5 minus 3x, also it becomes a negative or positive value. So those are we have to consider. Okay, so this is a wrong approach towards the problem. Right, so that's about it. I believe that I'll be making a part series. So this is the first part of it, and inshallah maybe in the future I might do a second part. Depends on myself. Okay, so thank you very much, and hopefully you guys are doing very well with what we have here. Okay, so I'll see you